Okay, let's have a look at the 2014 Unit 1, Semester 1 Technology Active Exam for Mathematical Methods. Alright, so here, once again, I'm going through the ones that I recommended on Compass. I don't know if there'll be any changes made to that. I haven't looked at this exam, so pretty much going to go on the fly. Let's see what we can do. So let's see, the gradient of the line joining the points 0 and 3, -6 and 0. So I'm looking at that and I'm thinking it's about 3, or 2 rather, but we'll have a look. So we're going to start at CAS. Now remember it's y2 minus y1 over x2 minus x1. So let's have this in the brackets. And then we'll put in the two y coordinates, so 0 and -3. So 0 minus -3. And then we'll put in our two x coordinates, which are, 0 and -3, so -6 and 0. It's got to be in the same order. So -6 and 0. There we go. Negative a half. So negative a half for that one, 0.5. Negative 0.5, let's just check. So that minus that gives us 12, and that minus that gives us 3. No, that's alright. No, 9. That works. So 0 minus -3, 0 minus -3, -6 minus 0, -6 minus 0, we end up with that. Okay, so the equation of a line passing through the point, the origin, and 5 and 10. So it's going through the origin, it's going through 0, 0. So it's going through, if it's going through 0, 0, let's have a look. Let's bring up the calculator page. So it's going through 0, 0, and then it's going through 5 and 10. So 0, 0, 1, 2, 3, 4, 5. It's going up 10. So that means it's gone across 5, up 10. So it's a run of 5, a rise of 10. So we've got a gradient of 2. Passes through the origin, we'll then see is equal to 0. So here we are. Ends up being 2x. Okay, let's move on to question 4. Notice I'm going to question 4. If f of 2 equals 0 and f of x is a cubic function, then a factor of f of x is, so this we're using the factor theorem or the remainder theorem that says if for a function f of x, if x minus a is a factor of that, then f of a equals 0. That's what we're saying for that one. So basically, whatever this is here, whatever we've got here, we swap the sign and we put it in there. So let's have a look. So here we have 2, so x minus 2 is then a factor. Alright, don't recommend question 5. Okay, question 6, the solution to a quadratic equation. Now, solutions is another way of saying the x-intercepts. So saying where x equals these values here. So that's what we're looking for. So with this, what are we going to do? We're going to let this equal 0 and solve it. So we're going to say solve 3x squared plus 11x minus 4 equals 0 for x. So -4 and a third. Is that one of the options? Yes, the first one, -4 and a third. How else can we solve that? Well, we could graph that thing there. So let's see if I can copy this. I'm going to right click, and you should be able to do this. Copy. Let's go to the graphing page. I'm going to paste it in. Graph that. There we are at a third. Oh, nice. Sorry. Let's see. We are at about a third and then -4. Is that what we said? A third and -4? Yep, there we go. So that works out well. Okay. Let's see. Skipping question 7 and 8. We're going on to 9. So we're told A is A, E, I, O, U, the vowels in the English alphabet, and then B is just looks like some other random numbers. We want A intersecting with B, so we're after the overlap, we're after those things together, what occurs in both of them. Having a look, we know these are the vowels, A, E, I, O, U, so we're looking at A, E, I, O, U here. E and U, there we go, that's what it is, and we've got nothing else there. Okay, question 10, the intersection of the line and the curve with equations below. So we're looking at where these two lines intersect. How do we let the lines intersect? Find out where the lines intersect? We let them equal each other. So that's what we do with CAS. So we'll say over here, solve, and we've got x minus 3 equals x squared minus 4x, x squared minus 4x minus 3 for x. So there we have x equals 0 or x equals 5. And remember, they're just x coordinates. So x coordinates are 0 and 5. So we've got 3 there, and we've got 2 that match up. So it says bottom 2 that match up. So then what we need to do is we need to take 0 and put it into x, because that's our x coordinate. So it ends up being here at e, because if x is 0, y is negative 3. If x is 0 here, y is negative 3 as well. We put in 5. 5 minus 3 gives us 2. So this is it here. Okay. Let's see. Look at what I'm skipping. Go on to question 12. So the equations of a parabola here. Now it's telling us we've got a turning point here at 2 and negative 1. So we want to turn it into, and we've got them all in expanded form. It's a bit of a problem. So we want it in turning point form. So give them a turning point. Now we don't know what A is, but we do have a bunch of values here. Now we see all the coefficients of x squared are 1, positive or negative. So based on that, our value of A is going to be positive. Oh, sorry, it's going to be 1. Whether it's positive or negative, oh, look at the shape of the graph. It's negative. Okay, so based on that, what we're going to do, we can just put that into CAS. So we'll say negative, negate. Open brackets, we'll say 2, negative 1, so it's x minus 2. Oops, x minus 2 all squared minus 1, so that's what we end up with. And we do that, and this is what we get. Negative x squared plus 4x minus 5, and that'll fit in. Negative x squared plus 4x minus 5. We have that there. Really important to recognize that the x-intercept, the y-intercept will be somewhere here, which is a lot less than negative 1. So yeah, negative 5 makes sense. Could also be negative 3, but that's not what the math tells us. The math tells us negative 5. Okay, so that's question 12 done. Let's have a look at 13. Alright, maximal domain and range for this thing here. If you're asked to find a maximal domain or a range, just graph the thing. So with this, we're going to graph this. We're going to go to our graph. We're going to go tab. We're going to delete this because we don't need it anymore. And it's a square root function, so let's say control that thing, and it's 9 minus x squared. 9 minus x squared. And there we go. So over here, we're at 0, 1, 2, 3. 1, 2, 3, so negative 3 to positive 3 is our domain, so it could be any of these 3 values. We have a look at the rest of them. 0 and 3, negative 3 to negative 3, 0 to infinity, it definitely doesn't go to infinity. Negative 3 doesn't go to negative 3, it goes to 0 and 3, so our answer here is B. Okay, now for this one, linear function, this has a range of that, so we want to see the domain. Okay, so with this, how can we solve this thing? So at one point, so the minimum of this function will be negative 7, the maximum will be 9. So what we'll do, let's graph this. Tab, let's go up, and like we said, it is 3 minus 2x. You can see what it's doing. So on the far left, so negative 7 is our lowest point, so that happens here. Negative 7 happens somewhere here. Okay, so the negative 7 is happening in the positive area. 1, 2, 3, 4, 5, so it's going to happen somewhere over here. That looks like it's going to be a maximum of 5. It's included, so it's going to be included here, so it looks like it's going to be one of these two options. Then 9, we can clearly see 9 is happening somewhere over here. So that's where it goes. So it's over here at negative 3 and 5. The other thing we can do is we can solve that thing. So let's go back, we can say solve. Negative 7 equals this. Negative 7 equals, oh no, damn. Let's start it up again. Come on. So basically what we're doing with that one is we're solving for x at the endpoints, and that gives the coordinates the gives the x coordinates the endpoints. Let's see if CAS works. I might pause this. How cool would it be if I could do that during class? Can't rub someone off the board, so we just pause it. People aren't listening, so I just pause it. Anyhow, alright, so what we're doing is we're letting this equal the y value and then solve for x, and that'll give us the corresponding x value. Alright, so let's try this again. Solve. -7. Yep. -7 equals 2 minus 3x. 3 minus 2 is 3 minus 2x for x. And it's at 5. So our where this is 7, it's 5. Let's do it again for 9. It's -3. So that's our domain. And remember, our domain is expressed just like the range, lowest to highest. So -3 to 5. So that ends up -3 to 5 will be A there. Okay, let's go on to question 14. Question 17. If A is less than 0 and x is an element of R, all real numbers, then the solutions to the equation this is R. Ugh, that's horrible. I'm going to solve that with CAS. So if I want this to equal 0, well, let's just see what we can do. So I'm going to graph that. I'm not going to graph it. I am going to type into CAS and see what we end up with. So we'll say solve x to the power of 4, x to the power of 4 plus x to the power of 3 minus ax squared minus a, and bring in times x, ax squared, squared, minus 2x squared minus 2x squared minus ax plus 2a minus ax, times x. Remember, if it's got the coefficient of variable, put the multiply in there. So otherwise I think it's x plus 2a equals 0. And we are solving that for x or for a? Yeah, solving that for x. Let's see what happens. X equals -a, and a is greater than 0, or x equals the square root of, so the negative square root of a, x is greater than 0, or x equals this a, and a is greater than 0, or x equals -2, or x equals -2, and a is greater than 0, or x equals 1. So what do we have here? Plus or minus that, -2 and 1, is that correct? Yeah, that's the one, so we go with that. So once again, we just go with that. Okay, question 18, the turning point of this thing here. So we've got a, x minus b squared plus c. We will end up with, so we want the turning point. So we know the turning point is, has to do with b and c. Now what we've got to do is we've also got to multiply this a through. So by multiplying this a through, we'll have a, and then instead of the square brackets, we'll have the a there. And then we've got to multiply this a through here, so we're going to be plus ac. So our turning point will be at b, comma AC. Now, do we have that here at all? Yes, there it is. It's there at D. So that's the end of the technology active questions for multiple choice. We'll have a look at the short answer ones. So just take a look at 20 just in case. Here's the one. Yep, not really technology active, but it's still a good question. We look at this thing, so it goes, there's a little factor there, goes up, down, there's a little bit of a cubic here at 1, and it goes that way. Now, it's starting off at negative, it's going back down to negative, so it's going to be a negative quartic. So, negative quartic, negative quartic, negative quartic, so it's going to be one of these two. Now, as well as that, we have got a point of inflection here at 1, so that's a cubic. So, at x minus 1, we want a cubic. So we've got x minus 1 here, we've got x minus 1 here, we've got x minus 1 here as well. This will not give us linear factor, but this will, and so with this. Like I said, it's a negative 40. So it ends up with this one. Let's just check to be sure. Open a new thing. Ooh, got 40 seconds. So let's be 15 minutes. So, oops, negative x minus 4, x plus 4. X plus 4, x plus 4 times x minus 1 whole cube. Yeah, here we go, that's going through there, that's going through there. In terms of what else we're seeing, yeah, we're not told what the y value is here, so then, yeah, that one works. So, just says anything else? No, that's it. Okay, let's pause that and have a look at technology active long answers in a minute.